Sorry, you guys, I got cut off for the time limit. So for the third one here, y is greater than or equal to 0. Here's y equals 0. Greater than 0 is this direction, like 1, 2, 3, 4, 5 is moving up. And then last is x is greater than or equal to 0. So if x is 0 is right here, greater than or equal is this direction. So normally what I will have you guys do is I will have you shade all of these and see where they overlap, but some students hate that and they think it gets really messy. But what you'll see is we're shading the upper side of the orange and the lower side of the red. So we are between these two. Then we are shading right of the purple and left of the blue, right and left of these, so we're between these. So between all of them, this is our feasible region. And just for fun fact, the vertices that we mentioned in the notes are 3, we'll call this one A, B, C, and D. So A, the coordinate for that vertice is 3, 0. B is 3, 1, 2, 3, 4, 5. C is 0, 5. And D is 0, 0. Yeah, 0, 0. So these are our vertices, just so you know what's what. Okay, now we're going to work backwards. So we need to write the inequality for the graphs shown. So first of all, this is a dotted line, which means we are using either this symbol or this symbol. It's got to be one of those two, okay? So let's figure out what the equation for the line is, and then we can determine which one to use. So the y-intercept in this one, my copy is kind of hard to see, but it looks like it's 1, 2, 3, 4, 5. So 5 is the y-intercept. The slope is negative, it's decreasing. So to find another nice coordinate, we look right here. What we have to do is go down 1, 2, 3, 4, and then forward 1, 2, 3. So our slope is -4/3, and then put an x on there. We need to compare that to y. Now here's the trick that my students noticed. I didn't actually notice this ever. I always did it the long way. So if the orange dot is our starting point, our cutoff, what y values are shaded? The y values that are bigger are shaded. Going vertically, going like north, going up is bigger. So we are going to use the greater than symbol. We're using y is bigger, okay? The y values above this, the numbers above that are shaded. That's why I use bigger, greater than. You can always test a point and make sure you're correct. So the next one, this is a solid line. So we are using this symbol or this symbol. And we need to find the y-intercept, which appears to be 1, 2, 3, -4. And the slope is going up. So we're going to go 1, 2, 3, 4, 5, 6. Here's our new coordinate. We're going to rise 1, 2, 3, 4. And we're going to run 2, but what is 4 divided by 2? That's actually 2, which means rise 2, run 1. Yep, we got a nice pretty point right there too. So our slope is 2. Now we need to compare that to y. So again, if we look where we started, if you look at the starting value of -4, the numbers on the y-axis that are colored are not these low ones are not colored in, just like these low ones. These were not colored. They were not included. If we go up, that is the way that we shaded. We shaded the upper portion. So we are again going to use the greater than symbol, but because it's a solid line, we need to use the greater than or equal to. Okay, last one. This one's weird, but we have a dotted line, so we're going to have to use this or this. And then we're just looking at the x numbers. We shaded 4, 5, 6, 7, 8, 9. 4 is what I call a boundary point. So the x values are greater than 4. The x's were bigger than 4. We used 5, 6, 7, 8, 9, 10. So this is our equation. It's a weird one to end on, but x's greater than 4 is what we're shaded. We're going to practice a little bit more with these, with boundary points and kind of more simple linear inequalities and inequalities before we get into some real heavy stuff on the next lesson. So if you guys would, go ahead and try worksheet 6.5 in your packet. Let me know what questions you have during class and we can work through them together. All right.